Okay, so here's some super nasty line integral I want to try to do to illustrate that we can do things that are more complicated. So I want to line integrate the vector field f, which is 2y comma negative 3, over the path 5 plus 4 cosine theta, comma 3 plus 2 sine theta. What the heck is that? Nice. Very nice. That is in fact an ellipse. Obviously, he says. It's obviously centered at. Sorry, I'm still getting used to the fez. Makes me taller. Should wear one every day. Or stilts. Or both.
You need to get one in different colors then. One for each day.
So I think this is centered at 5 comma 3.
Oh,
Yeah.
right.
Oh, right. Okay, cool. Now what? What do we do? This actually should be a pretty easy problem, right? Why should this be easy? Like, why is this easier than the other one? What is the thing on the board that makes this easy? No, none of you are pointing. Thank you, Railer, for pointing somewhere. This thing. This thing makes your life easier. Why does having c of theta make your life easier?
It gives us a function.
Aside from that one, obviously, because I was going to see in your.
Oh.
It's the path.
Oh, okay, yeah,
Right? They already gave me the path. That makes my life stupid easy. Right? Because normally the hard part is parameterizing the path. All I have to do with this path is plug it in the formula. Right?
Okay, I think yeah, that's done.
Okay. So, oh, I didn't give you a theta. There's your problem.
Yeah.
So, to go around the ellipse once, what can we assume about theta?
0 to pi.
Cool. So let's just assume theta is in 0 to 2 pi. And I guess we can close that end just for kicks. You guys all good with this? Okay. What do you do?
So do we split between x's and y's, or?
You can. Or you can do it the other way. I don't care. I'm going to do it the other way.
Okay.
I said I didn't care, but I did. So where do your thetas range? 0 to 2 pi. Okay. Then what should this first thing be?
2y negative 3.
Oh, we got just 2y, right? We're separately.
Oh, are we separate now?
I'm just going to do it in one thing using my notation, not the split up physics notation.
Okay.
So I should put 2y comma negative 3 here, you think?
That would be the f.
Okay, cool.
And then
What
we
else?
dot it with.
And then we need to dot with,
Do we do the c theta function? Or?
yeah, I need to dot with a parameterization of my curves. What? Prime. Thank you. So I need the derivative of c theta, right? Okay, so what do you get? -4 sine theta, comma 2 cosine theta, d theta. Okay. What'd you jack up?
There's not a y and a theta big jump that key.
Yeah, there's going to be a y in here, right? So what did I forget to do? Yeah, I wrote down f, right? I didn't write down f of r of t, or f evaluated at my curve, right? So what's y then?
3 plus 2 sine
No, it's not that.
Yeah, this part is x of theta, right? And this part is y of theta. So I really should have here the integral from 0 to 2 pi of 2 times that junk, which is 6 plus 4 sine theta, right? Comma negative 3. dotted with -4 sine theta, comma, 2 cosine theta,
Not theta, theta.
d theta. Cool? All right, then what?
Dot them?
Yeah, do the dot product and then integrate, right? Okay, so I got the integral from 0 to 2 pi of, whoa, nasty stuff. See, I think I got a -24 sine theta, right?
Minus 16
Minus 16
cents.
sine squared theta.
In parentheses plus.
Minus cosine theta.
I think minus 6 cosine theta.
Oh, yeah, I guess we can just ignore that.
D theta. Okay. Cool. Yes?
I mean,
Shit.
yeah.
Well,
What's up, guys?
You
Oh.
split it.
Split it. Into what?
3 pieces.
3 pieces. Okay, so I got -24 sine, -24, the integral from 0 to 2 pi of sine theta, d theta, minus 16, the integral from 0 to 2 pi of sine squared theta, d theta, minus 6, the integral from 0 to 2 pi of cosine theta, d theta.
No, it looks a lot better.
Jeezy Pete's, why was that better?
You're gonna get
I'm trying to swear less, give me a break.
Yeah. You're gonna get zeros or ones for the last, for the first and last.
I thought it was
Like, as a result.
Nice try, buddy.
Which 2 pi or 0.
No.
Well, at least we can integrate now.
So, what is this thing right here? That's the integral from 0 to 2 pi of sine, right?
Yeah.
That's an integral of a trig function over its entire period. What are you going to get?
oh, yeah, that's right.
No.
Zero.
Okay, sine works like this, right?
Yeah.
That's at pi,
Oh my gosh.
that's at 2 pi.
It vanishes.
This area and that area are
0,
the
9.
same and opposite, right?
Yeah.
Trig function over its period gives you 0.
So
How about that last thing?
Same thing.
Trig function over its period gives you 0. That's cool with that? Okay, so in the end here, I have minus 16, the integral from 0 to 2 pi of sine squared. You guys remember how to integrate sine squared? No! Don't be ridiculous. She said back of the book.
How
What?
the engineers do it.
No, it's not.
Yes, it is.
Yeah,
No. They know the one trig identity they need to know.
Do a
That's
trig
arc
sub.
sine. No, don't do a trig sub. Half angle identity.
Oh. Oh, I guess.
You guys don't remember this thing?
Yeah, you can do
It's
it.
the only trig identity you need to know. That and the Pythagorean theorem.
Yeah, we barely talked about it.
Okay, so what you need to know are these two. You need to know cosine squared of theta is 1 plus cosine 2 theta over 2. And sine squared of theta is 1 minus cosine squared over 2. Or, sorry, cosine of 2 theta over 2. Cool. You can get these out of the sum of angles identity if you really fiddle with it pretty hard. Cool. But for you guys, right, there's a 1, a cosine of 2 theta, and a 2, right? And the one that's cosine agrees, and the one that's sine doesn't agree. Cool? Put this in your bag of tricks. This is super useful to know.
Yep.
So you get out of this thing minus 16, the integral from 0 to 2 pi of 1/2 d theta minus 16, the integral from 0 to 2 pi of minus cosine 2 theta over 2 d theta. And I took a minus sign out of the second one because I realized that I was being redundant.
You just blow up one half.
You guys
Can
good
we
with
just
it?
move 1/2 on
And
this?
pull the 1/2, right? So that's a 1, and an 8, and an 8, and a cosine 2 theta.
You substitution?
No. Because it's easier than that.
No.
You're integrating from 0 to 2 pi a trig function over how many periods?
2.
2. That means a 0.
And then
And then you have this.
you owe 16 pies.
So you get negative 16 pi, which means what? That's how much work you would have to do to go around this path in that vector field, right? In other words, from this you can eyeball that the vector field is not helping. Right? It's fighting you. At least a little bit. At least sometimes.
That's why I said
Right? It's fighting you more often than it's helping you.
you have to eat
So
16
every
pies.
time
Yeah.
it's crossed out zero would be an instance where it's neither helping you nor hurting you, right?
Kinda, yeah. So I hesitate to split those out like that because those are just components, right? Like that's part of the, like this guy here, that's like part of the X component isn't helping or hurting me. And like this is part of the Y, or this is maybe the whole Y component. Yeah, so the whole Y component isn't helping or hurting. Okay, so I'm noticing that all of my kind of work is being done in part of the X component. Is that useful information? I don't know. If you want to figure out where to slap thrusters on this thing, maybe. But keep in mind, this guy is just, there's some positive work and some negative work that happen to cancel out, right? It's not that that component's 0, it's just that they happen to cancel. So you still can't get away with, thrusters in that direction. But that would be like the guy who knows that it's downhill to town, so he should be able to coast the whole way, right? It is generally downhill to town from here. Can you coast the whole way? No, you gotta get up onto Parrots Ferry at some point, right? A little bit of a hill there. Cool. Questions, thanks? No? Okay.